All right, next is Harry Ferguson, who will be speaking about the wide field instrument time domain processing at the SOC. Harry, you can share your screen.
And
again, yep, we can see it, and I'll give you a warning when you're down to 2 minutes.
Thank you very much. Okay, so this talk is very much aimed at stimulating people to think about what you want in a sort of a generic variability catalog or several generic variability catalogs from standard processing of essentially the non-bulge fields taken with the wide field instrument. And so I will sort of go through what the SOC is providing and what our plans are, and point out, places where we are making trades, and then hopefully people will have some input on that. So why is it not advancing? There we go. So the Space Telescope is providing for the mission planning and scheduling basic WFI data processing, meaning essentially taking out the instrument signature, and then providing the archive for all the observations. The WFI data gets split, and some of the higher level processing is done at the Institute and some is done at IPAC. And then there will be a community interface to the imaging data that I will mention as I go along. So this just gives you sort of a high level view. So exposure level processing takes place. The microlensing and CGI and spectroscopy high level processing happens at SSC. It all comes back to the archive. The science community will access things through a sort of uniform interface without having to worry in particular about where the data are. And then there will be a platform. The data products, there are various levels. The numbers are a little different from JWST, but same idea. The raw data, which I think most people won't need to touch, comes into the Institute. It gets metadata and formatting and so on at level 1. Level 2 processing essentially does the basic calibration, removes the instrument signatures, and does astrometric alignment. Level 3 is basically rectifying the images, co-adding them, producing images with, essentially north up, and the kinds of things that one uses typically at the survey level. Level 4 is basically catalogs and associated metadata. There will be a queryable empirical point spread function library. And level 5 data is data produced by the community and contributed back and available through the archive. So we expect at level 4 there'd be these static object catalogs and variability catalogs, and I will focus on the variability catalogs. Sorry, I should use there we go. So this is the basic data flow at level 2, and it's the standard data processing to do flat fielding and background subtraction and bias level. Pretty much only a couple of things are of interest to time domain in particular, although they're still of interest even for non-time domain. So I would say right now our plan doesn't include persistence correction. We are thinking of being able to flag persistence as a flag rather than a correction, but the details there haven't been worked out. So that might matter for people interested in very faint transients. We don't expect persistence to be a terribly serious effect in the Raman detectors. And then for very bright sources, the nonlinearity correction, could be important. Once again, I imagine this is it would be very rare where this matters, but those might be two areas where people interested in pushing the bounds of what you can do with time domain might want to look carefully at what we're planning to do and weigh in on that. Level 3 images are rectified and then combined. So multiple images will be combined. The readouts are non-destructive on Roman, so most of the cosmic rays are removed in the process of fitting the up the ramp sampling. But when you combine images, you do additional cosmic ray rejection. And that's another area where people interested, especially in fast transients or moving targets, they want to look carefully at what we're doing and weigh in on trades we're making that might affect their science. We also refine the image alignments here if needed, but we expect actually the astrometric alignment done at level 2 will make this unnecessary, whereas it's incredibly important for JWST and HST. I mentioned the public community contributed products. These are going to be quite important for Roman because these large survey teams doing some of the core science will have very valuable data products to contribute back, including things like photometric redshifts or joint photometry with complementary data sets from other facilities, value-added catalogs, so on and so forth. And the timing and details there have yet to be worked out. The science teams, in some sense, haven't yet been selected, although a lot of people have been thinking about it over the past 5 years or so. I mentioned there will be access to a sort of a community platform. We're calling the Roman Science Platform. It's cloud-based. It will be CPU close to the data on Amazon Web Services. The level 2 to level 4 products will be there, although the interface essentially will be transparent. If you're coming at it programmatically through Python or some other language, you won't necessarily need to care, although performance might be higher if you're on AWS and grabbing things that are on AWS. In any case, there'll be a full calibration pipeline installed and the Python and AstroPy ecosystem installed and configured. You can install your own packages, run your own code, and it's easy in this platform to scale resources up and down. I'm sorry for this. So the current plans are to produce static source catalogs. These will be fairly standard finding sources by convolving with a detection kernel that sort of emphasizes small galaxies, doing some deblending of overlapping sources, measuring fluxes through apertures with and without convolution by a PSF matching kernel to allow you to get decent photometric redshifts, measuring shapes, doing some star galaxy classification. Computing photometric redshifts, but this will only be done from the Roman data by the SOC. This is of more relevance to this conference is the variability catalogs. So these are to be run, there'll be 2 classes of these photometry-based variability catalogs where in some sense, you're measuring the photometry on an image that hasn't been subtracted, no other image has been subtracted. I would say it's still TBD whether this is PSF fitting photometry or aperture photometry with a PSF correction. And then there will be difference imaging catalogs that are made with convolution by a PSF matching kernel if needed, and subtracting a template image. As I mentioned in the previous talk, the bulge microlensing processing, high-level processing is completely distinct from what I just mentioned, and really tailored to the observing strategy and the science goals there. So it includes difference imaging, PSF photometry, simulations, event characterization, detection efficiency, things that are specific in many ways to that science case. For the non-bulge fields, we've looked at different strategies adopted for different surveys, and I want to briefly outline a few of those. So the Hubble Catalog of Variables is one of the precedents, the Zucchi transient factor is another, and then LSST plans are another. Trades include, do you do your photometry purely by catalog matching, which is what the Hubble Catalog of Variables did, and do you match individual epochs, or do you match to a deeper catalog, or do you do forced photometry? And then when to do the processing, do you try to do it in real time, or at a cadence where you have uniform data products? So this, I'm looking at the time, I'm going to rush through a little bit, but this sort of outlines these various approaches. I've circled here the various input data products. So you have the individual catalogs that are constructed sort of on a 6-month time scale from survey data. You have the combined co-added level 3 images, but you also have individual images that have been rectified but not co-added. And then you've got the level 2 images which haven't been rectified. You've got deep catalogs from these co-added images, but you've also got the individual catalogs from the non-co-added images. So in the Hubble-like approach, there's no new photometry. You only do the photometry epoch by epoch. You do catalog matching. This was really dictated by the way Hubble data were obtained and the fact that the surveys are very inhomogeneous. And even with a lot of careful processing there, the artifact rate is about 19%. And of course, Roman will be able to do much better. ZTF
you're under a minute. Sorry about that.
Yep. Yeah. ZTF makes a deep catalog from at least 15 epochs, position matches the individual PSF fit catalogs, but doesn't do forced photometry. Ruben's plan is to do forced photometry on a sort of a release product time scale, so 1-year time scale. They also produce prompt products, but those are from difference imaging, not this kind of forced photometry. The reference images will sort of be locked from release to release of this kind of variability catalog. And they plan to do a fair amount of characterization of variability. And so in any case, after doing this, one combines the time series and computes variability indices, does additional flagging, measures proper motions if possible. So this is sort of a straw man where the idea would be to do forced photometry at a sort of a data release time scale, meaning sort of 6-month-ish, measure the centroid of the source closest to the aperture center, try to figure out if it's shifted, because proper motions will be significant. If it's been shifted, do forced photometry at the shifted position. If not, which would be the most of the cases, do the forced photometry at the nominal, apply any photometric corrections, and then do the variability. As I say, this is very much a work in progress. The difference imaging would do PSF matching if necessary, subtract detect residuals above the threshold, and produce a difference imaging transient catalog. Open questions are, how do we construct the templates? How or even whether to do the PSF matching? Are the astrometric corrections going to be good enough? Will the jitter correction be small enough? Some of these will be hard to determine entirely before flight, but you have to decide how much to invest in complicated algorithms if you think it's not going to be a problem. So to conclude, with a stable PSF and a wide field of view, Roman is going to be amazing for time domain discoveries. The Science Operations Center is designing the pipeline, a basic pipeline for time domain catalogs, hopefully to serve a lot of the community. We are very interested in input from the time domain community, and now is a good time to have an influence on sort of major trades, which will be harder to make a year from now than they are over the coming year. Thank you very much.
Okay, thank you. We have time for one question. You have 2 questions in the chat. We'll go to Nino first. Can you say a few words where the target of opportunity data processing and availability fit in the processing flow? at what level will be distributed to the community proprietary period?
There is no proprietary period for any of the data, so that bit it will be the same as everything else, as far as I'm aware. I would say our plans are to process that data through the pipeline just like any other data. And so it will get standard data products, but I would say as far as the variability catalogs, it's not entirely obvious yet what that means, in the sense of we haven't decided whether we will do difference imaging sort of on the fly based on have there been previous observations of this field? Can we make a template on the fly and subtract it? Or rather to do that based on a template that's constructed from uniform data products only on the survey areas. So in some sense, we're interested in science use cases to help us decide what makes the most sense for serving the broadest community.
Okay, thank you. And Monsi has a question. You can answer this in the chat about whether near real-time alerts will be sent out for difference imaging. If you want to just go do a quick yes or no.
The answer is not in the plans right now.
Okay.
Corey, and there were two questions in the Zoom chat, but maybe Will and Adrian can take those to the Slack space.
Okay, perfect. Thank you for bringing that up. Yep, thank you. All right, thank you very much, Harry, one more time. Very nice talk.